Today we're going to talk about the perimeter and areas of similar figures. The most important thing you need to know is that if the scale factor of two similar shapes is A to B, then you know two things. First, you know that the ratio of the perimeters will simplify to be the exact same as the scale factor. Secondly, you know that the ratio of the areas of your similar figures is going to be the same as the scale factor fraction except squared. Here's an example to help you see why this pattern always holds true. Let's say you have two similar rectangles, one with sides that are 2 and 4, and one with sides that are 1 and 2. If you want to find the scale factor, you just pair up two corresponding sides and make a fraction, 1/2. Now, find the perimeter of each of those shapes. When you add up all the sides for the first one, 2 plus 4 plus 2 plus 4, you get 12. For the second one, when you add up all the sides for that perimeter, you get 6. When you make a ratio of your perimeters, you have, therefore, 6/12. That simplifies right back to the scale factor. So really this rule that the ratio of the perimeters is going to be identical to the scale factor really just means that whatever the ratios are, once you put them in a fraction, it'll just simplify to match your scale factor. Now let's find the areas of our two shapes. Because these are rectangles, you just do area equals base times height. You get area for the first one is 8. For the second one, the area is 2. So when you make a ratio or a fraction of the areas, you have 2/8. And that simplifies to 1/4. So that is your area ratio. Now here's the thing. Using this rule that the ratios of the areas is always a squared version of the scale factor, I could have gotten 1/4 a lot faster just by taking my scale factor and squaring it. If I take 1/2 and square the pieces, I still get 1/4. And that's a shortcut you're going to be practicing the use of today. So let's go through question 1 together. So here I have two similar figures, and they're asking for the ratio of the perimeters and the ratio of the areas. Notice how I can't even figure out what the whole perimeter of each shape is because I'm missing some of the sides. But that's okay, because for the ratio of what the perimeters would be when I simplified them, it would really be the same as the scale factor. I just need to make a fraction out of a pair of corresponding sides and simplify it. So I'm either going to get 4/3, or if I put it in the other order, starting with 9/12, it would have been 3/4, which is equally good. Just a quick tip, it's equally good to write 4/3 as it is to write 3/4 for your ratio of your perimeter answer. However, it is more common to write it so that the second shape is on top of the fraction. So most people would choose to write 12/9 instead of 9/12, though it's not required. Now I can't find the actual areas of my two shapes, but I can find the ratio of their areas because I just take my scale factor that I already figured out and square it. So the ratio of the areas would be 16/9. Go ahead and try the next two problems on your own. Pause the video until you're done. Go ahead and check your answers on question 2 and 3. One thing I'd like to point out is that your ratios never have units. The reason why is because the units actually get canceled out as if they were like terms in a fraction. For example, for number 3, when I had originally 8 inches over 6 inches, the inches would cancel out in the fraction. The units would be gone in my final answer. Go ahead and turn your paper over. Now, this rule about the ratio of perimeters and areas has some really useful implications. For example, you can start with knowing the area of two similar figures and work backwards to reverse engineer what the scale factor was. So here they tell me that the area of two similar figures is 32 square meters and 50 square meters. So I could start by making that into an area ratio, 50 over 32. If you put 32 over 50, that's equally good, but most people will put the second number on top of the fraction. Now I want to simplify that fraction. Both 50 and 32 can divide by 2, and I get that my simplified area ratio is 25 over 16. Now I know that my area ratio is the squared version of the scale factor. In other words, I could say that the scale factor squared equals 25 over 16. To figure out what my scale factor was, I just need to cancel out the squares. In other words, I need to square root both sides of my equation. To get just a over b, or just my scale factor, I would square root 25 over 16 and get 5 over 4. So now you have your scale factor is 5 over 4. You know the ratio of the perimeters is always going to simplify to be an identical answer to your scale factor, so part B is also 5 over 4. Go ahead and try question 5 on your own. Pause the video until you're done. Go ahead and check your answer. Quick note, if you wrote 1 over 2 instead of 2 over 1, that would be equally good. When we're talking about ratios, I would leave answers like 2 over 1 as a ratio, as a fraction, instead of a whole number, because it's really a comparison of two numbers when we're talking in terms of ratios. It's 2, 2, 1. Now let's take a look at number 6. The area of the smaller regular hexagon is about 127.3 square feet. What is the best approximation for the area of the larger regular hexagon? So whatever information I have in a word problem, I always like to add to my picture. So go ahead and add under the smaller regular hexagon that its area is 127.3. Make sure you write it under the smaller regular hexagon, not the larger one. Now, to find the area of the larger one, we can actually really go through the same process you did with the problem above. You can start by making your scale factor, and from that, your area ratio, since they're asking about area in this problem. And if you chose to write 10 over 7, that's equally good. Doesn't really matter, especially with these word problems, what order you put your scale factor in. So once you square your scale factor to get the ratio of the areas, this tells you something important. It tells you that the actual areas, whatever they are, would simplify to equal 49 over 100. And you can use that fact to make an equation. I would start with your area ratio, 49 over 100, and then I'd figure out whether 127.3 would have to simplify to be the 49 or the 100 when I simplified my actual area ratio. Because 127.3 is the area of the smaller shape, it would have to simplify to be the smaller of the two numbers. So I would line up the 127.3, so it's across from the 49. So they're both smaller shape over larger shape for both fractions. And then put an X for the missing area for the larger shape. And then I can cross multiply and get my final answer, that the larger shape has an area of about 259.8 square feet. Now it's hard to tell, but question 7 is really the exact same type of question as number 6. First, I would draw the picture they describe. So it will cost Maria $150 to have carpet installed in her room that measures 12 feet by 10 feet. So draw your 12 feet by 10 feet room. At this rate, how much would it cost her to have carpet installed in a similarly shaped family room with a larger dimension 18? So if the larger of the two sides is 18, it would line up with the 12, the larger of the two sides in the other shape. So I'd put the 18 here. There's one number from the word problem we haven't used yet, the cost. And this is where it gets interesting. Now the thing about carpet is sold by square feet. In other words, the more area of carpet you buy, the more you pay. So this $150 to carpet the first room is actually telling us the area of the first room. Our units for area are literally dollars. Now you can see how it's a lot like question 6. Go ahead and make your scale factor, square it to make your area ratio, set up your proportion, and cross multiply to solve. Pause the video until you're done. So you take the two corresponding sides you have to make your scale factor. I highly recommend simplifying it first, but fun fact, you'll get the same answer for x even if you don't simplify. Your numbers in the work will just be bigger until the very last step. After you have your scale factor, square it to find the area ratio. You have 9/4. Or if you wrote 4/9, that's equally good. Then set up your proportion. So 9/4 would equal x over 150. Because 150 is the area of the smaller shape, it would have to line up with the 4, the smaller of the two numbers in my area ratio. Cross multiply, and I get $337.50. Well done, everybody.